I'm going to show the answers to several of the questions posed at the end of the electric circuits lecture for physics in everyday life and conceptual physics. The first challenge asked you to build a working flashlight in the PhET simulator using wires, a battery, and a switch. So I have it here all set up. I have my battery. There are variations on this. You can hook things in different order, but I put my switch on the positive terminal of the battery. That switch connects to the tip of the bulb. Charge goes through the filament of the bulb, and then the side of the bulb connects to another wire, and those wires return back to the negative terminal of the battery. So if I close the switch to complete the circuit, I get light. The second challenge asked about different arrangements of the battery. And so I've actually arranged batteries a couple of different ways in here. I've built an identical circuit to my flashlight here, except I've put two batteries end to end. And this essentially is doubling the pumping power in this circuit, doubling the voltage of the batteries in this arrangement, doubles the amount of energy these batteries can deliver to the circuit. So when we close the switch, we should see the light bulb considerably lighter, simulated as being lighter than it was for the single battery. And notice the charges are flowing faster in this circuit as well. But you can also hook batteries so that the two positive ends of the battery are linked together and the two negative ends of the battery are linked together. This is actually called putting batteries in parallel with one another. And it turns out when you do this and close the switch, the light bulb actually is the exact same brightness as it was back here for the single battery circuit. And so doing this, well, I guess I threw the simulator for a loop because it doesn't show any charges moving in battery number 2. In reality, if you wired this up in this fashion, half of the charges would get pumped through battery number 1 and half would get pumped through battery number 2. So let's see if we can actually fix that, since the simulator doesn't seem to like us doing this. What happens if we put our battery over here? And just for fun, throw another switch in there. Close that. Whoa. Whoops. That's what happens when you short circuit. All right, we got the side of the bulb hooked here. This is going to be a little, let's see if the simulator will let me do this. Now we got to hook to the bottom of there to our battery. Spread things out a little bit. There. Now we have both batteries pumping charges, half of the charges that go through the bulb. So you get the same brightness of the bulb as a single battery, but both of the batteries actually do half as much work. So the advantage to wiring batteries in this fashion is that the batteries last longer. And the only place in my house where I know I have batteries wired in parallel like this is in my wireless mouse that I use with my computer, and that means I have to change the batteries in that half as often. The third simulation asked about, can you light multiple bulbs? And you indeed can. In fact, there's a couple of ways to do that. So here are bulbs all on one loop of conducting wire. And when we close this switch, both the bulbs light, but you'll notice that they're actually dimmer than the single bulb circuits, and the charges are moving faster. That's because we've actually increased the resistance in this circuit, since all the charges that are being pushed through the circuit by the battery have to flow through both light bulbs, both light bulb 1 and light bulb 2. And so the overall effect is to drop the current and to reduce the brightness of the light bulb. But you can also hook light bulbs like this so they each have their own independent path to the battery. So I can get light bulb 1 to light up on its own, or light bulb 2 to light up. And in fact, I can get both light bulb 1 and 2 to light up, and they're the same brightness as a single bulb. It's as if they each have their own independent connection to the battery. The first arrangement over on the left is known as a series circuit, where everything that's getting electrical power is in one conducting loop. The second one on the right is known as a parallel circuit, where there's an independent branch for each of the thing that's getting power here from the battery. And the one on the right is the same pattern that your house is wired in, because in your house you can use all of your electrical devices independently. You do not have to have your microwave on for the toaster to work or vice versa. They both work independently because they each have their own independent connection to the power supply. The final circuit I've built here is this 5-bulb circuit that was part of the questions for the survey, if you've gotten there. And the question asks, how many of these bulbs will light when the switch is closed? Well, the answer turns out to be 3. Bulb 1 here lights, bulbs 2 and 3 light, but the bulb up here does not light, nor does the bulb at the bottom. The bulb at the bottom doesn't light because only one side of that bulb is connected by a conducting wire to one portion of the battery. And you have to have both sides of the bulb connected to both sides of the battery in some fashion in order to get the bulb to light. The bulb at the top has connections to both terminals on the bulb, but both of those terminals are connected to the positive side of the battery. So there's no energy difference between the wire on one side of the bulb and the other. Hence, you get no flowing charge through this bulb, and this bulb stays off. Notice of the 3 bulbs that are lit, the bulb on top here is brightest, and that's because I have a combination of series and parallel features. The current that flows out of the battery goes into both of these bulbs down at the bottom equally. Those two are parallel to each other, and so they each get the same amount of electrical current. But all that electrical current then combines right here at this point before passing through the bulb on the top. That higher increased combined current makes the bulb here at the top brighter than the other 2 bulbs that are lit in this particular circuit.